Deep thunderstorms and tornadoes. Other severe local storms are thunderstorms and tornadoes. They are of short duration, occurring over a small area but are violent. Thunderstorms. These are caused by intense convection on moist hot days. Unstable moist air lifts up, and as air condenses it releases latent heat. This results in the formation of cumulus cloud, and when this process continues, it leads to formation of a cumulonimbus cloud. The thunderstorm is a well-known cumulonimbus cloud producing thunder and lightning. The thunderstorm is characterized by intensive draft of rising warm air, which causes the clouds to grow bigger and rise to greater height. This causes precipitation. Later, downdraft brings down to earth the cool air and the rain. Hailstorm. When the clouds extend to heights where sub-zero temperature prevails, hails are formed and they come down as hailstorm. Dust storm. If there is insufficient moisture, the thunderstorm can generate dust storms. Tornado. From severe thunderstorms, sometimes spiraling wind descends like the trunk of an elephant with great force, with very low pressure at the center, causing massive destruction on its way. Such a phenomenon is called a tornado. Tornadoes generally occur in middle latitudes. Sprouts. The tornado over the sea is called water sprouts. These violent storms are the manifestation of the atmosphere's adjustments to carrying energy distribution. The potential and heat energies are converted into kinetic energy in these storms, and the restless atmosphere again returns to its stable state. Local winds. These blow only during a particular period of the day or year in a small area. For example, land and sea breeze. Similarly, Lu is one. They are of following types. 8. Hot. Local hot winds are faint in Alps called Chinook in the USA and Sinum and the Northern India. Cold. These include Mistral and Caravuran Sea. Convectional. These are land and sea breeze. Deep slope winds. These are katabatic and anabatic winds, also called valley winds. Katabatic winds or drainage winds produced by the flow of cold air under the influence of gravity from higher to lower regions. During night, the upper slope being more exposed gets more cooled by larger back radiation of heat. The lower temperature produces high pressure. Air gets cooled, dense and heavy. The lower slope is relatively warmer and has lower pressure. The katabatic winds are also termed mountain breezes or gravity winds. Anabatic winds occur during the day. The upper slope gets heated and develops low pressure, while the lower slope remains relatively cooler. The higher pressure then promotes the upslope flow of air, and this produces the anabatic winds. Forces affecting the velocity and direction of wind. Pressure gradient. Pressure varies as latitude changes. Near the equator, the sea level pressure is low and the area is known as equatorial low. Along 30 degrees N and 30 OS are found the high pressure areas known as the subtropical heights. Further polewards along 60 ON and 60 OS, the low pressure belts are termed as the subpolar lows. Near the poles the pressure is high and it is known as the polar high. These pressure belts are not permanent and vary according to the position of the sun. In summers, they shift 5 to 10 degrees towards poles. This shift is observed maximum for the equatorial belt and minimum towards poles, and as sun moves, the movement of the belts also follow the same path. Low pressure areas. In areas where temperature is high, the air gets heated and rises. This creates a low pressure area. Low pressure is associated with cloudy skies and wet weather. High pressure areas. Areas having lower temperature, the air is cold. It is therefore heavy. Heavy air sinks and creates a high pressure area. High pressure is associated with clear and sunny skies. Frictional forces. These are prevalent only near surface of the earth and is almost negligent beyond 3 kilometers. Further, they are very low on sea surfaces. Coriolis force. The rotation of the earth about its axis affects the direction of the wind. This force is called the Coriolis force. It deflects the wind to the right direction in the northern hemisphere and to the left in the southern hemisphere. The deflection is more when the wind velocity is high. The Coriolis force is directly proportional to the angle of latitude. It is maximum at the poles and is absent at the equator. The higher the pressure gradient force, the more is the velocity of the wind and the larger is the deflection in the direction of wind. As a result of these two forces operating perpendicular to each other, in the low pressure areas the wind blows around it. At the equator, the co-realized force is zero and the wind blows perpendicular to the ice bars. The low pressure gets filled instead of getting intensified. That is the reason why tropical cyclones are not formed near the equator. Air mass and air mass is not same as wind. An air mass is a volume of air defined by its temperature and water vapor content. When the air remains over a homogeneous area for a sufficiently longer time, it acquires the characteristics of the area. The homogeneous regions can be the vast ocean surface or vast plains. The air with distinctive characteristics in terms of temperature and humidity is called an air mass. Air masses cover many hundreds or thousands of square miles, and adopt the characteristics of the surface below them. Thus these are huge masses of air at the lower part of troposphere near Earth's surface. The weather at a place's characteristics of the air mass that is affecting the place. Faster an air mass moves, faster the weather changes are. Accordingly, following the types of air masses are recognized by maritime tropical Mount II continental tropical Cort II maritime polar MPIB continental polar CPB continental Arctic CA. Tropical air masses are warm and polar air masses are cold. The figure shows the various sources of the air masses. Note that an air mass is not same as wind. An air mass is a volume of air defined by its temperature and water vapor content, and it is a much wider expanse in hundreds of miles, and it represents the weather of a place over which hovers. Fronts when two different air masses meet, the boundary zone between them is called a front. The process of formation of the front is known as frontogenesis. There are 4 types of fronts: A cold, B warm, C stationary, D occluded. I cold front. When the cold air moves towards the warm air mass, its contact zone is called the cold front. As the cold front nears your region, the barometer falls. The cold air behind the front wedges under the warm air and lifts it sharply off the ground. Large cumulonimbus clouds appear. These clouds often bring thunderstorms and rain showers. As the cold front passes, the wind changes direction. The weather becomes clear and colder and the barometer rises again. Warm front. Whereas if the warm air mass moves towards the cold air mass, the contact zone is a warm front. The warm air behind the front glides up and over the cold air. The barometer falls and a long, steady rain begins. Gradually, the front passes and the sky clears. Occluded front. When an air mass is fully lifted above the land surface, it is called the occluded front. Occluded front IT results when a cold air front overtakes a warm front and lifts the warm air mass completely off the ground. An occluded front forms when a cold front overtakes a slower moving warm front. The occluded front is more complicated than the others because 2 fronts interact. In the left diagram of the occluded front, colder air wedges under warm air at the cold front. Warm air glides up and over another cold air mass at the warm front. As shown in the right diagram of occluded front, the warm air is squeezed out and lifted above the ground. Steady rains falls at an occluded front. The fronts occur in middle latitudes and are characterized by steep gradient in temperature and pressure. They bring abrupt changes in temperature and cause the air to rise to form clouds and cause precipitation. The steeper the slope of the front, the more violent are the storms associated with it. The width of the front is usually 50 to 100 kilometers. However, on the scale of the diagrams, it looks like a line. Front policies, in contrary to areas of frontogenesis, the areas where air masses diverge are called areas of front policies. It is actually weakness or dissipation of the atmospheric front. Siberia and Canada are examples of areas of front policies. Geostrophic wind. The winds in the upper atmosphere, 2-3 kilometers above the surface, are free from frictional effect of the surface and are controlled mainly by the pressure gradient and the co-realized force. When ice bars are straight and when there is no friction, the pressure gradient force is balanced by the co-realized force and the resultant wind blows parallel to the ice bar. This wind is known as the geotrophic wind. Water cycle. Clouds and rain's absolute humidity. Water vapor present in the air is known as humidity. It is expressed quantitatively in different ways. The actual amount of the water vapor present in the atmosphere is known as the absolute humidity. It is the weight of water vapor per unit volume of air and is expressed in terms of grams per cubic meter. The ability of the air to hold water vapor depends entirely on its temperature. The absolute humidity differs from place to place on the surface of the Earth. Relative humidity, the percentage of moisture present in the atmosphere as compared to its full capacity at a given temperature, is known as the relative humidity. At night the maximum capacity is low, so relative humidity will be higher. Relative humidity is inversely proportional to temperature. Relative humidity is highest at equator and decreases towards the poles. It is minimum in subtropical anticyclones. With the change of air temperature, the capacity to retain moisture increases or decreases and the relative humidity is also affected. It is greater over the oceans and least over the continents. Dew point, the air containing moisture to its full capacity, i.e. air is saturated to 100% or relative humidity is 100%, at a given temperature is said to be saturated. It means that the air at a given temperature is incapable of holding any additional amount of moisture at that stage. The temperature at which saturation occurs in a given sample of air is known as dew point. When the temperature of the air falls below the dew point temperature, vapor condenses. Vapor upon condensation form liquid droplet, when dew point is greater than 0 degree. Vapor form ice crystal when dew point is less than 0 degree. In free air, condensation results from cooling around very small particles termed as hygroscopic condensation nuclei.